Alright, so this is 13.2 angle and angle measures. Our problems are 12, 13, 19, 25, 26, 27, 33, and 48. 25 through 27 are the biggies, the most kind of the most important part of 13.2. Let's open up the 13.2 though. We have our learning target. I can draw and find angles in standard position, and I can convert between degree measures and radian measures. The converting is the thing that I was saying. It's kind of that most important concept. Then we have angle measures. So a couple quick things. Here's the initial side. This is the ray that's this way. And then the side that's kind of moving is the terminal side. So that's there. Then you have angle measures. If your terminal side is going up and to the left, so counterclockwise, it's going to be positive angle. Down to the right, it's a negative angle. All right, so that's just a quick little thing there. Our first skills concept is, can you just draw an angle in standard position? So draw the angle. So 215. So if you notice in the red, here's where 215 is. And then you're just drawing your angle there. And we know it's positive, so we're going up and to the left first, counterclockwise. Negative 40. So here's negative 40. And you're going down to the right. Last part, 540. Now this is where we're starting here. And a full rotation is 360. And then add 90 on. You're at 450, and then add another 90 on, and you're at 540. All right, so it has this kind of snaking effect. Next part then is coterminal angles. So two or more angles in center position with the same terminal side. So if you have two more angles, you have a positive angle and a negative angle for 130. So what you're doing is you're taking 130, you're adding it to 360, so you get 410. Oh, sorry, 490. That says 490. This should say. There we go. So we'll rewrite it. 490. And then you take 130 and you minus it with 360, and you should get negative 230. All right. So for negative 45, you're doing the same thing. So you have negative 45 plus 360, so you get 315. And then negative 45 minus 360, and you get negative 405. All right, so that's kind of the first part of the concepts. That one's not as bad. It's pretty straightforward. The next part is converting between degrees and radians. So degrees and radians, basically what a radian is a complete revolution around the unit circle is 2 pi radians, right? With circles, we're always dealing with pi, and this is kind of the little dealio here. A nice little thought. So 2 pi radians is 360 degrees. 1 pi is 180 then. All right, very straightforward. And basically a radian, like this right here is 1/6. So 30 degrees is 1/6. It's just pi over 6 because it's 1/6. So you did 1/6 of a rotation for 180. Now for the entire circle, it's 1/12. Okay, right, because you go 30, 30, 30, 30, 30, 30, 30. But just for one rotation, or not one, a half rotation, it would be 1/6 of the circle, 1/12 for a full rotation. So let's write actually pi over 12 for radians. All right. We'll find out in a second what it really is. Are we going off of the full 360? Or are we going 180? We'll talk about that in a second. Now to convert between degrees and radians, you are going to use these two parts right here. If you're going from degree to radian, you're going to multiply the degree by this. If you're going from radian to degrees, you're multiplying it by this. So here we have degrees, so we're going degree to radian. So we take negative 30 degrees, and you're multiplying it with pi over 180. All right, so this is pi radians over 180. I'll put a 1 down there so then we can see kind of the multiplication. Now we're just going to multiply across. So you get negative 30 pi over 180. Now we can just simplify, and you get 30, negative 30, so you get negative pi over 6. How do we get negative pi over 6? You have 30 divided by 180, both divisible by 30. So if you divide by 30, you get negative 1 on top. Divide by 30 here, you get 6. And then we just have that pi left over. Second part, now we have 120 degrees. So you can do the same thing. So you have 120 over 1 equals, not equals, sorry, multiplies with pi over 180. This gets you 120 pi over 180. And you can simplify this down to 2 over 3 pi. So how many radians is it? It's 2/3 pi radians. Alright. So 2 pi over 3 radians, 2/3 pi over radians, whatever you want to say it. Here, so this is degree to radians. Here, this is radians 2 degrees. Alright. So you have 5 pi over 2, and you're going to multiply that with 180 over pi. Alright. So on the top, 5 times 180, you're going to get 900. On the bottom, you get 2 pi. Oh, forgot pi on top. There you go. So you have 900 pi over 2 pi. The pi's cancel out, right? In degrees, you're not going to have pi's anyway, so the pi's should always cancel out. Then you have 900 divided by 2 is 450 degrees. So 5 pi over 2 radians is 450 degrees, right? And we can kind of think about that for a second as well, because if we know that just 2 pi is 360, so here's 2 pi, so that's 2 over 2. Do it again, that's 4 over 2, and then a half is 90, so that's 360 plus 90, 450. So it works with this circle. Then we have, again, the last one, 3 over 8 pi, times that with 180 over pi, so you get negative 540 pi over 8 pi. Pi's cancel out. And you get negative 540 divided by 8 is negative 67.5 degrees. Alright, so that's basically how you kind of do those problems. Those are kind of the most important ones. And then our last part is arc length. Right here is your formula. So S, so arc length is S, that's our symbol for it. Okay. R is the radius, and this theta is the angle in radians. Alright, so if you have radians, you're going to use the S equals that. Alright, so for this example, it says the diameter is 9, so that means the radius is 4.5, right? The radius is half the diameter. And it says our central angle is 60 degrees. So our first step is we need to convert this to radians. So we go from degrees to radians. So you have 60 over 1 times pi over 180. So you get 60 pi over 180. So you get pi over 3. Alright, so now this is what our theta is pi over 3. So now our arc length S equals, our radius is 4.5 times pi over 3. So 4.5 times pi is 14.14. Divide that by 3. And your arc length is 4.71 centimeters. Alright, so that's kind of pretty straightforward. Just go off of this. The other thing that you couldn't do is if, say you are given degrees and you're like, well, I don't want to move it to radians. The proportion there, in case you don't want to use proportion or radians, is length over 2 times pi equals x over 360. This is only if you have degrees. And we'll make this S. So this is your arc length is S. Okay? So your homework's over here. One quick thing with number 33. It's kind of grainy, so. But this is 3 pi over 7. And this is 5 centimeters. So just want to make sure I clarified that for you. But other than that, you have the questions. And this is 13.2.